Welcome to Basic Technology for JSS 3. Today we study logic gates, the building blocks of all digital computers and electronic devices. What is digital electronics? In digital electronics, signals are represented by only two states, high 1 equals a voltage present, e.g., 5V or 3.3V. Low 0 equals no voltage, 0V. This binary, two-value, system is the foundation of all computers, smartphones, calculators, and digital devices. Logic gates are the basic building blocks that process these digital signals. What is a logic gate? A logic gate is an electronic circuit that has one or more inputs and one output. The output depends on the logical combination of the input according to a specific rule. Each type of gate follows a truth table, a table that shows the output for every possible combination of inputs. The three basic logic gates. 1. The AND gate. Symbol, a D-shape, flat side on the left where inputs go, curved side on the right where output comes out. Rule, the output is high, 1, only if all inputs are high, 1. If any input is low or 0, the output is low or 0. Think of it as, all inputs must be 1 for output to be 1. Truth table for two input AND gate, input A equals 0, B equals 0, output equals 0. A equals 0, B equals 1, output equals 0. A equals 1, B equals 0, output equals 0. A equals 1, B equals 1, output equals 1. Only when both are 1 is the output 1. Real-life analogy, a house alarm sounds only when an intruder detected and the alarm is armed. Both conditions must be true. 2. The OR gate. Symbol, a curved shape, curved on both sides, with a curved input side. Rule, the output is high, 1, if at least one input is high, 1. The output is low, 0, only if all inputs are low, 0. Think of it as, any input being 1 makes the output 1. Truth table for two input OR gates, A equals 0, B equals 0, output equals 0. A equals 0, B equals 1, output equals 1. A equals 1, B equals 0, output equals 1. A equals 1, B equals 1, output equals 1. Only when both are 0 is the output 0. Real-life analogy, a bus door opens if either the driver presses the button or a sensor detects a passenger. 3. The NOT gate, inverter. Symbol, a triangle pointing right with a small circle, bubble, at the output tip. Rule, the output is the opposite, complement, of the input. If input is 1, output is 0. If input is 0, output is 1. The NOT gate has only one input and one output. Truth table, input equals 0, output equals 1. Input equals 1, output equals 0. Real-life analogy, a light switch, when the switch is on, 1, the light is off, 0, when the switch is off, 0, the light is on, 1. Boolean algebra. Logic gates are described using Boolean algebra, named after mathematician George Boole, and is written as y equals ab or y equals ab. Or is written as y equals a plus b, not is written as y equals a bar or y equals a or y equals a. Combined logic gates. Logic gates can be combined to produce more complex circuits. NAND gate equals NOT plus AND gate followed by a NOT. Output is 0 only when all inputs are 1, otherwise 1. NOR gate equals NOT plus OR. Output is 1 only when all inputs are 0, otherwise 0. XOR gate, exclusive or output is 1 only when inputs are different, 1 is 0 and 1 is 1. Importance of logic gates. All digital devices, computers, phones, calculators, digital watches, are built from millions, or billions, of logic gates. Modern processors contain billions of transistors, which implement logic gates. Logic gates are used in arithmetic circuits, adding numbers, memory circuits, control circuits, multiplexers, decoders, comparators. Remember, digital electronics equals signals represented by two states only. High 1 equals voltage present, e.g. 5V, low 0 equals no voltage, 0V. Binary system equals foundation of all computers plus smartphones plus calculators. Logic gate equals electronic circuit with one or more inputs and one output. Output depends on logical combination of inputs. Each gate follows truth table, shows output for every possible combination of inputs. 3 basic logic gates. AND gate, rule equals output high, 1, only if all inputs are high, 1 if any input is low, 0, output is low, 0. Think, all inputs must be 1 for output to be 1. Truth table, 2 input 0 plus 0 is equal to 0, 0 plus 1 is equal to 0, 1 plus 0 is equal to 0, 1 plus 1 equals 1, only when both are 1 is output 1. Analogy, house alarm sounds only when intruder detected and alarm is armed. OR gate, rule equals output high, 1, if at least one input high, 1 output low, 0, only if all inputs low, 0. Think, any input being 1 makes output 1. Truth table, 2 input 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 equals 1, only when both are 0 is output 0. Analogy, bus door opens if either driver presses button or sensor detects passenger. NOT gate/inverter, rule equals output is opposite, complement, of input, input equals 1 output equals 0, input equals 0 output equals 1, has only one input and one output. Truth table, 0 1, 1 0. Analogy, light switch on equals 1 light OFF equals 0, OFF equals 0 light on equals 1. Boolean algebra, and equals y equals a b or y equals a b, or equals y equals a plus b, not equals y equals a bar combined gates, NAND equals not plus and followed by not, output equals 0 only when all inputs are 1, NOR equals not plus or, output equals 1 only when all inputs are 0, XOR/exclusive or, output equals 1 only when inputs are different. Importance, all digital devices, computers plus phones plus calculators plus digital watches, built from millions or billions of logic gates. Modern processors contain billions of transistors implementing logic gates, used in arithmetic circuits plus memory circuits plus control circuits. Thank you for studying basic technology with us today.